Hi everyone. Hi everyone, I'm Dmitry Ganev, a software engineer at VMware Carbon Black, and I'm going to introduce you to our newest connector / integration for threat intelligence. So let's get started. Let's start with what is threat intelligence. So what is STIX first? STIX is an abbreviation for Structured Threat Information Expression, and it stores information about attackers in the real world, and it's standard for exchanging threat information. So STIX solidifies the exchange of data between various organizations, and it's making it easier for experts to analyze threat intelligence, specify patterns for threat intelligence, and managing threat response activities and sharing threat intelligence information. In simple terms, you can say, for example, some IP is malicious and is being used by some threat actor to send a malware which is having some file hash that can be expressed in STIX. The information about this is stored as an object, which you'll see in the next slide. So what is taxi? Taxi is the transport protocol used to distribute STIX information, and it is being used specifically for STIX. So basically, it's a web server that distributes STIX data. You can see that. You can exchange threat intelligence with other vendors and share threat intelligence feeds. So what are SDOs? That is an abbreviation for STIX domain objects. And so these objects are representing threat intelligence, and they are being used, as I said earlier, to express certain patterns or some kind of attack. So here we have 6 SDOs out of 18 in total. And on the picture on the left, you can see how those SDOs are related to each other. So in this case, we have a campaign that targets some vulnerability, which is another SDO. And it is attributed to a threat actor, which is, again, an object. And we have on top of that, we have an indicator, which basically indicates a campaign and a threat actor. So the indicator is it has relationships with both of those objects. This is a rather small example of what STIX is capable of. The current example can have other objects, such as course of action, which will tell the security experts how to react in that case. For example, block some port number to mitigate the campaign, and so on. The course of action object has a field called action, and that field can be used to automate the applying of patches and so on. For example, reconfigure firewalls and so on. So here is what an indicator object looks like in its JSON schema. You can see that it has a name of malicious URL, and the description is basically this URL is potentially associated with malicious activity. And on the pattern field, we have the URL in question. So in this case, it's malware.indicator.url. So from that indicator, we understand that this URL is malicious. And this is the indicator object in the JSON. So let's move on to the taxi server. So what is taxi first? It's an abbreviation for trusted automated exchange of intelligence information. And as I said, it is a transport protocol used to distribute STIX information. It uses the HTTPS protocol. Overall, this is a web API. It has some routes for pushing and pulling STIX information, and it is designed specifically for STIX. The taxi servers are supporting multiple collections with feeds simultaneously. It also supports public and private feeds. So what is a threat intelligence feed? This is basically a list which has some STIX information in it, represented in JSON. and the feeds can be specialized. For example, on the one side, we can have some indicators for malicious URLs in some region, and on the other feed, we can have the same thing but for another region. And then the user can decide which feed to use based on the region. And a collection is just a list of feeds. So collection can have a lot of feeds, and each taxi server can have a lot of collections. So that's about what is threat intelligence and what is sticks and taxi. Now we can move to our connector. So the CVC Threat Intelligence Connector is a tool that can automate the ingestion and the translation of sticks that is provided by some taxi servers into the Carbon Black Cloud. It's all in one solution. That means that you won't need any other tools besides this one to ingest threat intelligence. And it's an open source. It's also available in the Python package index. It's a CLI tool, which means that it runs in the command line. It is highly customizable and easily extensible. I'll example how so in the next slides. And it's written in Python. So on the picture on the right, we can see the threat intelligence connector. In this case, it sits in the middle, and it has 3 taxi servers. The threat intelligence connector can pull each 3 of them for threat intelligence data, and you can see that each taxi server is returning a different kind of information. On the left, you can see the taxi server is returning JSON. On the right, you can see the taxi server is returning XML. So the threat intelligence connector can process both JSON and XML, which are corresponding to the sticks version. In the case of XML, it is sticks1, and in the case of JSON, it's sticks2. So the connector supports both of those versions. And then the connector translates those sticks information into the Carbon Black Cloud. The translation, the threat intelligence connector is translating them to IOCs. So IOC is an indicator of compromise, and it pushes those IOCs into the Carbon Black Cloud. Then they get distributed into a different Carbon Black Cloud feeds. And a more elaborative picture will come into the next slides. So more about the functionality. So the tool can process files directly. As I said, XML for sticks1 and JSON for sticks2. Again, as I said, it can process multiple taxi servers. Again, it supports both taxi1 and taxi2 servers. It's highly customizable. It can be used as a module and a CLI tool. And it is documented with examples. We have a well-documented guide into the Carbon Black Cloud developer network. So you can see there. Now, this is an example of the CLI tool. You can see that we first install the connector with pip install, and then we can use it. In this case, I've run it with with the help option, and you can see what commands do we have. So we have create feed, create watch list, we have process file, process server, and version. In the demo, I will demo some of those functions. And this is how the parsing of a taxi server looks like. So we run the process server command with the config file. The config file is storing our configuration for the taxi server. So in this case, it is pulling some taxi.server. It processes the indicators that are into the feed that you've specified in the config.yaml. And in the end, it prints successfully imported the custom feed into the CVC. Here is a more elaborative diagram of how the threat intelligence connector works. So after it translates STIX data, it pushes that STIX data into the Carbon Black Cloud, and then it gets distributed into the feeds, and the IOCs then get distributed again into a bunch of reports. So each report is containing a bunch of IOCs. So here is how to extend the tool. It's rather simple. You can use the tool with third-party solutions such as Airflow. You can use the module to create some Airflow DAGs or Airflow operators, and you can configure it with Airflow. You can incorporate the tool into your existing tools and pipelines. That's why I've included an example here how to use it as a model with some code. And you can use the existing example with Docker in the repository for the threat intelligence connector. We have a example with Docker, how to run the connector with Docker, and we also have a guide into the developer network, how to do that. So let's get started to the demo. This is the page for the Carbon Black Cloud threat intelligence connector, and now we can install it. Actually, we have to create a virtual environment first. So deactivate the environment, and then we can install the connector. We successfully installed the connector. Now we can run the CLI tool that the connector comes with. So that's CVC Threat Intel, and that will give us some various options that we can use the CVC Threat Intel connector. So we are going to create a feed first so that we can process the taxi servers into a feed. So we can run create feed, and that will give us an example usage of that command, the arguments that it needs, and some options. We can create a feed, for example, VM explore test feed, and we're gonna specify the URL for that feed. Actually, let's put it on loopback, and then the summary for that feed, I'll just put it on empty, and that will create the feed for us. As you can see, we have the ID here, and the category is text. We can now edit the configuration file that I've created earlier. So I'm gonna edit it, and we can see the feed ID. Right here. I'm gonna delete the current configuration, and I'll put the new feed ID that we've just created. Now we can run the process server command. First let's run it with help. You can see that it expects option, which is config file, so I'm gonna specify it. That is the current configuration. And that will start parsing the taxi server. As you can see, we have successfully imported the OTX alien vaults into CVC. So let's check that out. We can go through here. We see a list with feeds. So let's check our feed. And here we have it, VMware export test feed, and we can see the 4 reports that are being created, and each report have
has around, let's see, okay, so we have about 4K IOCs. We have about 1K here, and those three have 1K, and this one has 600, almost 700. This is because we limit the amount of IOCs in each report. And that's about the connector. You can see more information here on the Carbon Black Cloud developers under documentations. Then you can go to integrations, and then we have threat intelligence connector right here. And here we've put a guide which is pretty well documented with a lot of useful ways to use the connector, such as using it as a connector as a Python model, using it with a cron job, how to build and run the Docker file, and so on. We have known problems and helpful links. And that's about the demo.
Thank you for your time.